Hello friends, this video on Ray Optics part 49 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 48 before going ahead with part 49. Let us try to solve some problems. So the problem says that a person with normal near point, that is 25 centimeters, using a compound microscope with objective of focal length 8 millimeters and an eyepiece of focal length 2.5 centimeters. That means it has a compound microscope, that is a small objective and a big eyepiece, right? So it says that the focal length of objective is 8 millimeter, which is equal to 0.8 centimeters. Focal length of the eyepiece is 2.5 centimeters. It can bring an object placed at 9 millimeter from the objective. That means the object is located at a distance of 9 millimeter from the objective. So U is equal to minus 9 millimeter, which is minus 0.9 centimeters from the objective in sharp focus. What is the separation between the lenses? So now if it is bringing the image of this object in sharp focus, that means that sharp focus means it is at a distance of distinct vision, which is 25 centimeters. That means the image is formed at a distance of 25 centimeters. Right? Now, the image is formed on this side. So, this image will act as an object for the eyepiece. Right? So, what is the question asking about? It is asking us to calculate the separation between the two lenses. That means we have to calculate this entire distance. Now, this object will form an image somewhere here. So, this distance would be the image distance from objective plus the object distance from the eyepiece. So, we have to calculate V0 and UE, right? So, what is this 25 centimeters? 25 centimeters is nothing but the image formed by the eyepiece, because it is telling about the final image formed, right? It says that this compound microscope can bring an object placed at 9 millimeter from the objective in sharp focus. That means this is the final image formed by the compound microscope. That means the final image formed by the eyepiece. So let us use the thin lens formula for the eyepiece, that is 1 by VE minus 1 by UE is equal to 1 by FE. So we can write it 1 by minus 25 minus 1 by UE is equal to 1 by 2.5. So from this we find UE is equal to minus 2.27 centimeters. Now let us apply the same formula for the objective. So this is 1 by VO minus 1 by UO is equal to 1 by FO. Or we can write 1 by VO minus 1 by UO. UO is nothing but this U. So this is minus 0.9 is equal to 1 by 0.8. So from this we get VO is equal to 7.2 centimeters. Therefore, the separation between the lenses will be VO plus UE, that is equal to 2.27 plus 7.2, which comes out to be 9.47 centimeters. Right? Okay. So now the second part of the question asks us to calculate the magnifying power of the microscope. So how do we calculate the magnifying power of a microscope? Now, magnifying power in this case would be equal to magnifying power of objective multiplied by magnifying power of eyepiece. So in this case, magnifying power of this objective is nothing but height of image by object, which can be written as V by U, that is VO by UO. And what is the magnifying power of the eyepiece? Eyepiece of a compound microscope behaves in a similar way as that of simple microscope. And in this case, the object is at a near distance. So this will be 1 plus D by FE. Now what is this D? D is the distance of distinct vision. In this case, D is nothing but VE. That is the final image formed by the object, right? Which is the image at a near point. So now if we put these values, it is 7.2 divided by 0.9 into 1 plus 25 divided by 2.5. So this comes out to be 88. So 88 is the magnifying power of this microscope. Now let us go ahead and look at the next problem. It says that a small telescope has an objective lens of focal length 144 centimeters and an eyepiece of focal length 6 centimeters. What is the magnifying power of the telescope? So how do we calculate magnifying power of a telescope? Here, focal length of the objective is given as 144 centimeters. Focal length of the eyepiece is given as 6 centimeters. We already calculated that magnifying power of a telescope is given by FO by FE, so which is equal to 144 by 6, that is 24. So this is the magnifying power. We also have to calculate the separation between the objective and the eyepiece. So separation here in this case will be equal to FO plus FE, because in case of a telescope, the second focus point of the objective is the same as the first focus point of the eyepiece. So the separation will be FO plus FE, that is 144 plus 6, which is equal to 150 centimeters. Right? So now let us go ahead and look at the last problem of this section. An angular magnification or magnifying power of 30x is desired using an objective of focal length 1.25 centimeters and an eyepiece of focal length 5 centimeters. So we have an objective and an eyepiece. So how will you set up the compound microscope? So basically we have to calculate the magnification as well as we have to calculate the distance between the objective and the eyepiece. So in this case, the total magnifying power is given as 30. Now we know that the total magnifying power is the product of the magnifying power of the objective and the magnifying power of the eyepiece. So this is equal to 30. Right? Now we also know that magnifying power of eyepiece is given by 1 plus D by FE, where D is nothing but the distance of distinct vision, that which is 25 centimeters, right? So this will be equal to 1 plus 25 divided by 5, which comes out to be 6. And what is magnification of the objective? That is nothing but V by U. So what is V? That is VO by UO. Now what is VO in this case? That is the, it is minus VO by UO. So in this case, we can say that what is this magnification of the objective? From this we can say that magnification of objective is equal to 30 divided by magnification of the eyepiece. So we can say here MO is equal to 30 divided by ME is equal to minus VO by UO. So what is ME? ME is 6. So therefore we can say 30 by 6 is equal to minus VO by UO. So from this we get VO is equal to minus 5 UO. So now we apply lens formula. So lens formula says 1 by V O minus 1 by UO is equal to 1 by FO. So here instead of VO, I write it as 1 by minus 5 UO minus 1 by UO is equal to 1 by FO. So now solving after this, what do we get? We get minus 1 minus 5 divided by 5 UO is equal to 1 by FO. Or we can say minus 6 by 5 UO is equal to 1 by FO. Or UO is equal to minus 1.25 into 6 divided by 5, which comes out to be 1.5 centimeters. So UO, that is the distance of the object from the objective, is minus 1.5 centimeters. So the object should be placed at a distance of 1.5 centimeters from the objective. And where will be the image formed by the objective? It will be minus 5 into U0, which is equal to minus 5 into minus 1.5, which is 7.5 centimeters. So this UO and VO together explains the entire setup of the compound microscope in order to get this desired magnification. So I hope that now when we have reached to the end of the lesson, you have understood the topics related to ray optics, and you have also got some idea regarding how to approach to solve problems based on whatever we studied so far. So what I suggest you as always is try to solve more and more problems so that you gain confidence in problem solving, and always be clear with your concepts. So hope this lesson benefited you. So see you all in the next lesson. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.